question is, the point O is 1.2 meter below the rough horizontal ground ABC. A ball is projected from O with a speed of 25 meter per second at an angle of 70 degree to the horizontal. The ball passes over a point A after traveling a horizontal distance of 2 meter. The ball subsequently bounces and off the ground at B. The ball leaves B with a speed of 15 meter per second and travels further 20 meter before landing at C, as in figure. So we will discuss the figure later on. So calculate, first part, calculate the height above the level O of the ball when it is vertically above A. B, calculate the time after the instant of projection when the ball reaches point B. And finally, find the angle which the trajectory of the ball makes with the horizontal immediately after it bounces at B. And in this case, we are going to take G as 10. So first of all, the given figure, which is like this. So this is point O and this is point A, and ball is projected from O it reaches this point B, and from point B it again bounces and finally touches the point C. Let us suppose this is point Q. The distance between OQ, that is horizontal distance, is given as 2 meter. The vertical distance is given as 1.2 meter. From B to C, this distance is given as 20 meter. Let us suppose the initial velocity is UA and it is projected at an angle of 70 degree, and here the initial velocity is UB and let us suppose the angle of projection is theta. So this is given. So in the first case, we are going to find out the height above, vertically above A. So then we are going to find out the time it takes from A to reach A prime, which is just vertical above point A. So let us say that it takes time t from O to A prime. Then the horizontal distance in this time period, the horizontal distance that is covered in t will be equal to OQ, and this will be equal to horizontal velocity of U, that is UAX multiplied by time t, and we can find out that UAX will be equal to UA cos of 70, where UA is given as 25 meter per second. Its vertical component UAY can be written as UA sin 70, and acceleration in y direction will be equal to minus g is equal to minus 10 meter per second square. So we can find out that the horizontal distance covered in time t, that is OQ, we already know is given as 2. UAX is given as UA cos of 70, so that will be UA cos of 70 multiplied by t. So from here we can write t is equal to 2, UA is 25, so we write 25 multiplied by cos of 70, and this will be coming as 0.234 seconds. So within time t, this, or we can say in time t, it is going to reach from 0 to a prime. Now we find out the vertical distance covered within this time period. Vertical distance covered in time t. So that will be equal to q a prime is equal to, so we can write this as s vertical distance in y direction u by t plus 1/2 ay t square. So sy is given as oa prime is equal to uy is ua sin 70 minus 1/2, sorry, multiplied by t multiplied by 10 into t square. So we already know value of t, so we substitute this as oa prime is equal to u is 25 into sine 70 multiplied by 0.234 minus 5 into 0.234 and its square. You can say that OA prime will be coming as 5.22 meters. This was our first part. The second part, so we are going to assume that in the original question it was given that it is projected from A and it lands at point B. So we extend this OQ in a horizontal direction and we assume that this projectile passes through B and lands at a point B prime which is at the same level as O. Then we can say that the time of flight between O and B prime, you can say that time of flight for OB prime, and let us call this as capital T. Now the horizontal distance, the vertical distance covered by between B and B prime will be same, that is QA. So let us call this as time T prime. You can say that time taken from B to B prime, let us call this as T prime. Then the time taken from O to B can be written as total time minus T prime. So we already know that the time of flight for projectile is given as 2UA sin 70 divided by G. So we put the values, we get 2UA is 25 sin 70 divided by 10. So we get this as T is equal to 4.70 seconds. Now for QA distance we find T prime. For QA, so we can write this as SY is equal to u by t plus 1/2 gt square. So sy is qa, and qa already we know that is given 1/2, and uy is ua sine of 70, so we can say 25 sine of 70, and multiply by t prime minus half to 10 multiplied by t prime square. So this equation will be coming as equal to 5 t prime square minus 23.5 t prime plus 1.2 is equal to 0. So this is a quadratic. We can say that t prime will be equal to 0.12 seconds. So we can find out the time of flight between from O to B. So from O to B, time taken will be equal to value of t is 4.70 minus t prime is 0.12, and this will be coming as 4.58 seconds. Now we are supposed to find out what will be the angle of projection from point B. So we can say that at point B, we already know that UB is given as 15 and range is given as 20 meter. So the formula for range is equal to u square b sine of 2 theta divided by g. So we can write this as 20 is equal to UB is 15 square sine 2 theta divided by 10, or sine 2 theta is equal to 0.8889. 2 theta will be coming as 62.74. So this we can say that theta will be equal to 62.74 divided by 2, and that will be equal to 31.37. This is the angle of projection at point B. Thank you.